Hey everybody, it's Alex with Engineering Applied. In this video, I'll be giving you a detailed overview of the transitional constraint found within an Autodesk Inventor assembly file. If you want more easy to understand and practical content like this, made by an experienced engineer like myself, make sure you like this video, subscribe to the channel, and turn on notifications so you don't miss out on any helpful content like this in the future. If you're looking for a specific function, check the description for timestamps. And if you don't find what you're looking for in this video, make sure you check out the other videos in the Autodesk Inventor series playlist because I know you'll find exactly what you need there. Let's get started. Okay, everybody, so here we are in our assembly file. And for the practical example that's tied to this lesson, we'll be taking a look at a valve train assembly that I went ahead and modeled up. And so this would correspond to either an intake or an exhaust valve in an engine. And what makes up this assembly is a camshaft that rotates. And as this cam rotates around, it pushes up on this follower assembly, which then makes this side of this rocker arm push down on the valve, okay? And when this valve goes down, it allows either air to come into the cylinder, or if it's an exhaust valve, it will let the exhaust gases out of the cylinder. So where does this transitional constraint come into play? Well, in this particular example, we're going to use it to hold the cylindrical face of this roller that's attached to the follower assembly to the face of this cam. So as the cam rotates, it pushes up on this follower, okay? So all we have to do in this particular case, now that the rest of our assembly is put into place, is go into our constrain section under the relationships part of the ribbon, and then we'll go to the transitional tab. So actually, before we apply this constraint, I'm going to just step through the major sections that are part of this field, and then we can go ahead and apply this constraint. And then I'll drive the rotation of the cam so you can see everything working together. So starting with our first section, which is the type section, this is where conventionally all of our various constraint types within our tabs are housed. However, with the transitional constraint, we only have this single type, which is just the standard transitional constraint. Okay, so like if you were to go to the motion tab, you have a couple different variants there. If you go to assembly, you have several different variants there. However, like I said, in transitional, we just have the single type. Okay, moving on to our selection section. This is where our selection filters are housed. And these will essentially just let us pick up the geometrical elements that we're going to use to set these constraints with. So conventionally, the first selection filter will be pre-selected, and I know it's pre-selected because it has a blue fill inside of the box. And when I hover over this, you'll notice it says moving face. So in this case, my moving face is going to be this roller on the follower assembly because it's going to be moving up and down. Okay, so the second selection filter is the transitional face. So this is the continuous series of faces or a continuous surface that this roller will travel on. Okay, so that is your second selection filter. Next, we have our pick part first option. So currently it's toggled off. So essentially all this does is it allows us to pick our part body first and then select the specific face we want to use for this transitional constraint. So for example, I'll leave it off and we'll go back to our first selection filter. And you'll notice when I hover over various parts in this model, it picks up this specific face on the part. Now, when I toggle it on, it picks up the entire part itself first. So this becomes very useful for when you have a complex assembly or maybe assembly where you have several sub-assemblies housed within one another and you can't quite reach that face of interest that you want to use for this transitional constraint. So what you do is you make sure that box is toggled on and you can go ahead and select the component or sub-assembly or part of interest and notice that it highlights everything green. So we're going to left click on that. And then now we can select the face of interest. So even when this face here on the roller is hidden behind this valve and its enclosure, we can go ahead and still pick up that face. It's not actually highlighting anything that's associated with this stuff over here. So let's go ahead and do that. So I'll pick up that face there and it'll jump to the second selection filter automatically. And let's do the same thing for this cam. Okay, so we're going to select the entire camshaft. And then we're going to select the face on this cam. And then now we've created that relationship between those two faces. Next, let's go ahead and take a look at the show preview option. So currently it's enabled, and I know it's enabled because there's a check inside of this checkbox. So leaving that activated, let's go ahead and select our two faces of interest, and let's take note of what happens with our preview. So I'll select this face here and this face on the cam, and you'll notice that the follower assembly snaps down to the cam. Now let's go back and uncheck this option and see what happens. So I'm back in my transitional constraint menu and I've unchecked this box here for show preview. And we're going to make the same two selections. So we'll select this face in this face. And notice how the follower assembly does not jump down to the cam surface. But when we hit either apply or OK, it completes that constraint operation, and this part snaps down to this part. Moving down, let's go ahead and take a look at this extended menu. To access this menu, all you have to do is click these arrows in the bottom right-hand corner of this window. And you'll notice we can provide a custom name for this constraint. So let's go ahead and do that now. I'll call this cam follower interface. Okay. If you don't enter a name into this field, it will put down the word transitional and whatever index number after that. So if you make your first transitional constraint, it'll say transitional 1, and then so on and so forth as you continue making those constraints. Okay. So we'll go ahead and select our two faces of interest, which will be the face of this roller here and the face of the cam. We'll click OK. And now you'll notice that under the relationships folder, I have the cam follower interface transitional constraint that I just made. So let's go ahead and drive this assembly. To drive this assembly, we're going to rotate this camshaft. And how we do that is we're going to drive this camshaft drive angle constraint that I made between the XZ plane of the origin and the XY plane of the camshaft. Okay, so there's an angle constraint between these two entities, and I can drive that angle constraint, which will drive the movement of the rest of the assembly. Let's go up here to our camshaft drive angle constraint. We're going to right click on that and we're going to go to drive. Okay, and so now we have our drive window here, and let's open up our additional options. So one thing that I want to note here is that this spring that I put into the assembly, so this valve spring, is an adaptive part. So essentially what happens as this follower moves up and this rocker arm pushes down and then this retainer goes down, the spring is redrawn several different times as this assembly moves. So it's really important that when you have adaptive parts in your assembly, and you know they're adaptive with this little blue and red arrow here in the cyclical motion, you want to make sure that you have this drive adaptivity option checked. If you don't have that checked, your simulation could break, okay? So let's go ahead and just show you what this looks like before we mess with any options. We'll go ahead and hit play. Our cam is going to rotate, and as it pushes up on that follower, you see everything is moving down on the other end of the assembly, and that spring is compressed. So let's see that again. So it's pushing up on the follower, down on the rocker arm, and down on the valve. Okay, so that is what our transitional constraint allows us to do. Let's get another view of that. So we'll go ahead and drive that again. Right click, drive. Let's hit play. Pay attention to the follower on the surface of the cam. You see how it's riding along the surface of that cam? That is what the transitional constraint is doing for us. Okay, see it a second time, and it rides smoothly along that surface. Now, before I go ahead and finish up this video, I want to discuss some troubleshooting options that are available to us when our simulation just isn't quite working out for us. So when I initially set up this constraint, I had this increment value set to amount of value in 1 degree. So that's the default setting. And when I hit play, this cam will rotate around, but you'll notice when it gets to the peak of this cam lobe here, it will fail. So the simulation will fail. And you'll see that here in just a second. So I get this little pop-up that says cannot solve at or near this point. So all I had to do in this particular case was change the increment value to a different number. So you can speed up the simulation by increasing this number or decreasing the total number of steps. So let's set a total number of steps of 400. And let's go ahead and drive this. So I'll hit play. You'll see that it moves a little bit faster because the number of steps has gone down. And now as we go over the peak of that cam lobe, the simulation is running properly. So before you go and start changing a bunch of stuff in your assembly, make sure you check out this parameter first and test it with a different value to see if that is the issue. Another thing I'm going to demonstrate here is I'm going to disable the drive adaptivity option within this menu. And I want to show you how this fails when I have an adaptive part within my assembly. Okay, so I'll go ahead and drive this assembly now without that option checked. And as soon as it gets to redrawing, or to the point where it should be redrawing this spring as it compresses, the simulation fails. So like I said previously, if you have adaptive parts in your assembly, make sure you have that option checked so everything runs smoothly. That's all for this segment of the Autodesk Inventor Assembly Creation module, where I gave you an overview of the transitional constraint. I really hope that you found this tutorial to be helpful and that you put what you've learned into practice so you can continue developing your skills as you work your way through these lessons. Also, before you watch the next video in the series, make sure you subscribe to my channel and turn on notifications to stay up to date on future content that will help you create the future you want for yourself. And of course, don't hesitate to leave a comment or reach out via my website contact page and let me know if there's anything else you'd like to learn about or see on this channel. I really appreciate you choosing to stop by and learn with me, and I'll see you again soon.